Right, so we can now summarize what we've learned so far as follows in one truth table, which I call the ultimate truth table. Right, so we begin with our two input variables, p and q in this case. So q can be 0 or q can be 1. Repeat the pattern, q can be 0 or q can be 1. Double the pattern up, so p can be 0, p can be 0, double 1. It gives us our four possible inputs. Right, talking about not q. Not q, if I'm looking at q, remember what not does, it simply toggles the state of all the variables. So zeros become ones and ones become zeros. Right, looking now at and, remember the short circuit definition of and. This certainly will make life easier if you can remember it. And the short circuit definition is basically that if I find a 0 in any of the inputs, then the output must be 0. So if we start with column P, you can see very clearly those two inputs there are 0, which means the output for P and Q must be 0. Moving on to Q now, that input over there is a 0, so I can carry that through. That is a 0, and which leaves us the two values to check very carefully, which is all the inputs are 1s. If all the inputs are 1s, if all the inputs are true, then and only then will an AND evaluate to true. Moving on to the OR. If you remember, we have the short circuit definition that we're looking for, that 1 anywhere on any of the inputs gives us the output of a 1. Alright, so we'll start with P, and so what we're doing is we're hunting down and looking for where we have a 1 as an input. So those two entries over there are both 1, which means the output for P or Q must be a 1 because one of the inputs is a 1. Right, moving on to Q, we definitely have a 1 in this row, so we'll put a 1 over there, and which leaves the only row that we need to check very carefully is 0 or 0. This gives us the result of a 0 as expected. So to summarize, and evaluates to true if and only if all the results or all the inputs are 1s, whereas OR is almost the logical opposite, but not quite. OR evaluates to 0 if and only if all the inputs are 0, which means we have the short circuit definition. We look for the opposite. So if any input is a 0, then for an AND we get a 0 as an output. Or with regards to OR, if any input is a 1, then automatically we get a 1 out on an OR, and we only get a 0 out on an OR when all the inputs are 0. Right, so in fact, this truth table here, this ultimate truth table, is the only thing you really need to study and learn, because it summarizes everything. We have on it all the different notations you could have for not Q, Q dash, or the all sideways LQ. Also for AND, we've got P and Q, P dot Q, P cut off A Q for an AND, whereas OR is P or Q, P plus Q, or P V Q, using the alternative notation. The short circuit definition for AND, we'll hunt for zeros. Any 0 in gives us a 0 out. Short circuit definition for the OR is any 1 in gives us a 1 out. We also have the circuit diagram for the NOT, being the triangle with an open bowl on it. The definition or the circuit diagram for an AND is the gate has a flat tail and a rounded nose, whereas an OR has a rounded tail and a very pointy nose.